we have some simple properties of the derivative, and they give some rules, some theorems about properties of integral. For example, if we have a constant k and a function f, and we differentiate this product, then this is k times the derivative of f alone. So as a result, this multiplicative constant remains as a multiplicative constant even for integration. Namely, if we have a constant and a function and we integrate, then we can factor out the constant k in front of the integral. And this is equal to k times integral of f. Similarly, if we have two functions and we add them, then the derivative is sum of derivatives. And as a consequence, if we add two functions and we integrate, then this is equal to integral of f plus integral of t. So that was for the indefinite integral, and now what about the definite integral? If we remind what we mean by the definite integral from a to b of f of x dx, then this is the antiderivative capital F at b, the upper limit, minus the antiderivative at a. So if we take the definite integral here, then the definite integral of constant times a function is again constant times definite integral from a to b. Similarly, if we have here integral of sum in the definite integral, then this is the same for definite integrals with the same limits, a, b, b. Well, obviously, if you replace plus with minus, then we have the difference of the derivatives, and if we write minus here, we have minus here, both for definite and indefinite integral. Plus, minus, there are four operations like plus, minus, times, division. Unfortunately, there is no such simple rule for product of functions and for ratio of functions. We will come to this difficulty in a few moments. And for the definite integral, we have two more rules. Namely, if we integrate from a to b plus integral from b to c of the same function, then this is antiderivative at b minus antiderivative at a plus antiderivative, well, let me write it here. This is antiderivative at b minus antiderivative at a plus antiderivative at c minus antiderivative at b. But you see the very first and the very last term cancel each other, and we have fc minus fa. But this is just a definite integral from a to c. This rule will be very obvious, very natural in a few seconds when we consider the geometrical meaning of the definite integral. And also, if you swap the limits a and b, then you just interchange these two terms and you get the same result as with the opposite side. So we can write that integral from a to b of a function is minus integral from b to a of the same function as a direct consequence of this definition of the definite integral. Yeah, we could perhaps illustrate some of these rules. Say, consider integral of e to x plus sine of x dx. So integral of sum is sum of integrals. So this is religion S. Integral of e to x dx plus integral of sine x dx. But now integral of e to x is e to x plus c plus, and integral of sine is minus cosine. And we can consider just one integration constant. Because if you write plus c1 plus c2 to each of the two terms, then you can consider this sum of constants as just one single constant.